Hello everyone and welcome into yet another live stream. And actually we should change the title because we probably won't be doing math animations this stream. Probably something different like chemistry, energy in chemistry. Yeah, that's much better. Now, hi. How is everyone doing? Just play some music. Like so. Great. Really glad to hear you're doing great. Really glad. I really am glad now. This. And there we go. Hi to Gabriel. You know what, Gabriel, who isn't? I just agree, who isn't? So, today I feel we could maybe walk in a chemistry video. How about that? That seems fun. That seems like a fun time. Hi, why Sadie today? Oh, I haven't seen you, Sadie, in such a long time. Why Sadie? Next stream's gonna be lit. Why? Because it's 110? We don't actually celebrate the 10s for some weird reason. Should I celebrate the 10s? Thing like coming today. Ah, I see. I get it. You know, sometimes these days like them just happen. Okay. Chemistry. I know last time we already tried looking for a chemistry textbook, but this time it's gonna be a different one. This time it's for chemistry, it's just physics rather than... So, statistical thermodynamics. 608 because of the thumbnail. Did I not change the thumbnail? Oh, I'm so sorry. I am so sorry. Today is the lit day. 609. Get funny. In 2 months, it's gonna be 69. Every 3 months we have it 69. At this point, oh, we also had a 420 stream too. Oh, in 2 months it's also gonna be 666. I'll have to buy the Doom DLCs for that stream. There. What's the video going to be about? Oh, I am so glad you asked, TCG. You see, this video will be about chemistry in the end, and physics, classical mechanics to be exact, in the very beginning. And the basic progression I'd like to go with this video is chemistry, at the very end, as I mentioned. And then, oh, I already have one source. I'll have to look into that, see if it's any good. But classical mechanics, thermodynamics, and statistical thermodynamics. Oh, damn it, give me a second, I need to fix this again. Something just happens every now and then. There we go. Fixed, I think. Whole textbook just dedicated to statistical thermodynamics. How convenient is that? Really convenient. And yeah, this is actually the ending with macro exactly what we're looking for. Huh. Maybe seems like exactly what we're looking for. Yup. Quantum and classical statistics. Is it quantum statistics as in statistics for quantum mechanics or quantum statistics as in quantized statistics? Okay. If you consider you're a genius and bro, hit me with this. Square root of negative 16. Oh no. Oh no. What did you answer? I mean, it's difficult, you know. There's like, you need to solve multiplication in there. A root of 16 is not difficult, it's not easy to find. I should drink some coffee. Yeah. I just woke up, I'm groggy, I need my go-go juice. Yummy! I think it's around 3.8573758388828I. Yeah, I would say it's around, yeah, I would say that's close enough. Roughly 3.8573758388828I. Roughly there. Particle velocity. Yup, the N19 classical point particle evolves by this. Okay, so we have statistical thermodynamics. Right here. I'm hoping I would need a textbook for classical mechanics. I sure hope I won't need a textbook for that. However, I may be dumb, but I'm not an idiot. It's better to find a textbook for thermodynamics. Or at least... Okay, maybe bookshelves would be easier. Tempting, but no. This one is great because it ends right where we want it to end. It ends with chemistry. Raise it to 16th power. I'm so lost. I am so lost. I'm joking. Okay, I see. Alright. For a second I was so lost and I felt that I was missing something because I haven't awakened yet. I mentioned I just woke up. I did. So I'm sorry if I'm a bit lagging behind on the stream. I thought my brain just wasn't mapping. Okay. Basics of statistical mechanics. Would be lovely, certainly. It's 11 PM. That's it. So what? Don't let society tell you when to fall asleep, when to wake up. If I wanna engage in my God-given right to sleep for 16 hours, then none of you heretics is gonna stop me. Can try. Jimmy Tatum, I think I've read something by him. Oh, that makes sense. Actually, yeah, it makes sense a lot. That was just, yeah, okay. Never mind, I need more coffee. Alright. Bast opinion, not gonna lie, I agree. Oh, we should say bust instead of base. That's such a much nicer tone. Bust. I like it. Yeah, we should say bust instead of based. Okay, calories, heat, and energy. Quantity, small, okay, this is all... Yeah, no. This is all no. Partial derivatives. There we go. Chapter 2. Partial derivatives. Partial derivatives as a concept aren't difficult at all in the slightest. The tricky bit is using them. Usually I say always essentially to indicate the subject which quantities are being held constant. It makes it sound more free vibe again. First attempts pronunciation die. Partial dz by dy. That actually also makes sense. We can approximate 1 plus 1. One guy on YouTube. You can approximate 1 plus 1? Is it doable? What was one of them where there's no like approximation, we don't know what it's equal to. Like we needed like a transcendental number for that, I thought. I don't know, maybe I'm just thinking about something different. No, I think it was it, right? You need a transcendental number, like pi. A variable, okay, we will increase, cool. Equation 225 can be solved the problem of... That's from the previous freaking chapter! 225. This one. Alright, can be solved the problem of the differentiation of an implicit function. Because the example, the unlikely equation... This. Calculator would be easy if you want to write this from y is equal to something. But it is difficult. I'll notify y explicit function of x. Implicitly relates y to x, so we're gonna calculate dy dx. Isn't 1 plus 1 equal to even an axiom? I don't know, I don't think you need it, math. No, I feel like axioms of math are much more annoying and vague. Actually, quite the opposite of vague, I suppose. I don't think you can use math as an axiom of math. Observing the surface is equal to this with plane O. Derivative can be thus the limit as x y approach the ratio. To make it seem the background's really nice. Constant and hence equal to 0. This equation gives us this. This is complex maths. And it's not even complex maths. Get it? Because complex can mean, you know, I'm gonna just drink my coffee in silent idea, fine. Okay. X, Y, and Z are latent in some equation that is algebraic manipulation. We can write in terms of as we can write x equal function of this, y is equal z is equal to z of this. Okay. Then we have this mess. I mean, lovely thing. And then we have this thing. Okay. X can be varied independently, and x and y can be varied independently. The only way in which equations that these two are can always be true is for all equations in parentheses to be 0. That kind of tracks. Does it? Gee whiz. Make it, you know, it would be a great idea if you just woke up, started the live stream and went straight for thermodynamics with partial derivatives. That would be just an exquisite idea. I regret my life choices. Okay. 300 plus page book. I don't think it has actually that many pages. That's the upside of LibraText. LibraText is dense. Not as in dense as an insult, only dense as in dense in knowledge. So this is a tad more difficult than it could have been, but the upside is you can fit the whole page like this, right? That's the entire page. It gives you a lot of information in a little time, which is nice. It's good. It's good. But not for me. I just woke up. I want something simpler. Just, you know. It's not that I need it, but I do need it. I am struggling. Hi, the ninja. I remember correctly, there's a book about proving 1 + 1 = 2 using axioms. Wait, 300 pages though? Do you need 300 pages to prove something based on an axiom? But is that really true? I'm gonna look up axioms in math. I'm gonna look up axioms in math. List of axioms, gimme. Yeah, I remember that these are just annoying. Boy, you're gonna make me... I don't want to go through axioms. 300 pages though. 300 pages doesn't seem right to me. I know that the proof would be really annoying to... Yeah, it would be certainly really annoying. But I don't think it will be that long. Unless I am making something up. Actually, I can just look up proof of 1 + 1 = 2 using axioms. That's not how we spell it. There is a post on Stack Exchange, of course there is. Hi, this is Entry. There we go! Hey, Gabriel! See, it's not that long. This looks like what someone would do in a movie to represent like alien writing. I'm streaming 4 AM. Hey, welcome, Zentry. Switch my stream times. This really does look like something someone would write on. I mean, jeez. Gee whiz. Look at me twice. Yeah, because I'm just such a welcoming guy, you know. What you doing? I am trying to get the information required, not quite script yet. I get the information required for this video. For the statistical thermodynamics and thermodynamics chapter. However, thermodynamics chapter we might just omit researching for, because it won't be nearly as difficult as this thermodynamics. Or it might be. I don't want to just go with the ideal gas law. That's too basic. On one hand, I don't want to go with only the ideal gas law. On the other hand, I don't want to push thermodynamics into it. I could just go for this statistical thermodynamics. Basic assumptions of statistical thermodynamics. Hi, the spoon. I'm doing great. I mean, really well. No mistaken, the picture you showed is from a book, Principia Mathematica. Yes. And I mean, I think I get what you mean. Mathematica, sorry. I mean, I get what you mean. Like, this is proof, if I'm not mistaken. If I do remember this notation, this is proof number 5443, and it is dependent on other proofs. Which means, yeah, I get it. In order to get to this point, you do need to get a lot of other things. This is page 379. Egg on my face. Egg on my face. That's 400 pages of dense mathematical writing to prove that 1 + 1 = 2. Egg on my face. 400 pages of about as dense as you can get mathematics to prove 1 + 1 = 2 based on the axioms. That would make for a pretty solid video. Keep doing well. I'm trying my best. Okay. I don't want to say hi, I can't stay, sorry, I also already make it. Hopefully I catch your stream tomorrow. Good luck with the research for the vid. Well, thank you so much, Zentre, for joining in. I really appreciate it, I really do. And good luck with whatever you're doing. Have fun, good luck, have a good day. It's a very controversial topic. What would you expect? With the 1 + 1 = 2? Yeah, I know. The mathematicians are still contesting it. I've known some people who would disagree. Wasn't there like a whole proof that square root of 2 = 1, I think? And then compare it to Principia Mathematica. Your name isn't Markiplier, dog that can explode. Ha! Fool me once, shame on me. Fool me twice. It's kind of also shame on me, honestly. I think it's 1 + 1 = 3. I mean, listen, unless we go through the entire proof, we don't know. Like, we can't be sure unless we go through the entire proof and actually check. So I'm just saying, I feel like we should leave this one open to interpretation, okay? I don't think 1 + 1 = 2 is that important mathematics. I feel like it's safer, it's a safer approach to just assume that we don't know, we're not certain, and only then come back to it. You know? Okay, now back to thermodynamics based on statistical mechanics. Once again, I have to rush. Is it a good idea to rush through it? I don't want to just read the entire textbook. Well, first things first, even if I wanted to, I first need to check what the license is on it. Have you ever watched Mathis animation? I don't know. I've seen one of the first videos of... I know what channel you're talking about, and I remember I have seen the old videos back when they came out, but ever since they got popular, I haven't seen all that many of their videos. 1 + 1 = 65. As I mentioned, it's a controversial topic, okay? We can't say for sure what 1 + 1 is equal to unless we go through the entire proof, so we probably should just... Mechanics of my not number. Attribution, non-commercial, unported. Appropriate credit. This isn't really a commercial purpose, is it? Is it? No, it's not. As if I'm making money off this. Adapt. Well, we're going for adapting and attribution. Maybogna from Ed Zurich. And also, let me just pop it into the description in case any one of you wants to read along. You know, that's a great idea. In case any one of you wants to just go for it and study along some statistical thermodynamics. Sounds like an extremely fun time. my face when 1 plus 1 approaches infinity. How can it, how can it approach infinity? What's the variable there? What 1 plus 1 is matters on the context of the question. I guess, suppose. It does. Let me just have another sip. My left hand hurts like crazy. For some reason, for the past month at this point, every single part of my fleshy, rotting human body is just hurting. I know it's a common opinion, but I just crave the certainty and of steel and the blessed machine. This day 609, nice. I know, right? It is nice. When I describe relations between observable quantities that characterize microscopic material objects, we know these objects consist of a large number of small particles, molecules, or atoms, and for all we know, these small particles adhere to the laws of quantum mechanics and often in good approximation to the laws of Newtonian mechanics. Statistical mechanics is the theory that explains macroscopic properties. Normally, thermodynamics functions by applying probability theory to mechanical equations of motions, large and small particles. Intellectual course we consider with the base statistical mechanics related to fundamental thermodynamics. I see. Thermodynamics based. I mean, I do believe it's based on thermodynamics. I'm so funny. Bye, TCG. Bye. Have a good one. Good night. Good night, I suppose. Phenomenological thermodynamics is essentially a static theory that proves an observational macroscopic definition of matter. The underlying mechanical description is dynamical and microscopic, but it is observational. Oh, more coffee. Would love to. Only for systems consisting of small numbers of particles. To see this, we consider a system of n identical classical point particles that adhere to Newton's equations of motions. You always stream like 3 AM here though. I'm sorry, I'll try streaming earlier on, okay? Tomorrow I'll try streaming in the morning. 5 in the morning, that's when I'll stream. Bye, Spoon is live, bye, have a good one. Particle mass M containing coordinates. Okay, and velocity coordinates. A system and a classical point particles are borne by this. Okay, so mass and that's energy, correct? No, it's the second derivative. No, that's 4. No, hold on. Acceleration. Mass times acceleration, that's force. This is, if I remember correctly, potential energy. That would make sense, yes, certainly. And that's derivative of potential energy in relation to position, but it's in the negative, which tracks with potential energy. Okay, so this is just standard effect of potential energy equation. Oh, where V is the potential energy function. I could have just read ahead. Okay, that's fair. The dynamical state of the system at any instant is defined by the 6n Cartesian and velocity coordinates. Of the system of the system in dynamic space is called the trajectory. Alright. The concept extends easily to atoms with different masses, mi. If we could, at any instant, precisely measure all 6n dynamical coordinates, spatial coordinates, and velocities, we could precisely predict the future trajectory. The system, as described by Newtonian equations of motion, behaves deterministically. That makes sense, I suppose. It does. Okay, so this is just... So far we're doing just classical mechanics with a twist. Well, not quite a twist, just doing classical mechanics. There's no I call it action because there's a fun. What is I call it action? Fun math question. It's from Cambridge entrance exam. It was really fun. X to the 5th minus 1 equals 0. You gotta find all 5 solutions. That sounds like pain. That's not fun. That's torture. That's what the 5th circle of hell is all about. 5th stands for the 5th exponent. That's the higher you go, the more exponents you just have. No, that's not fun. X equals to 1. That's okay, that's my one solution. Y'all now have to find the rest. Good luck. Okay. Yeah, listen, I have an idea. We all have to contribute something. I'm gonna contribute my solution, which is x equals to 1. Okay, that's my solution. Now all of you need to 1 negative 1. Oh, I already called 1. So, and also I'm pretty certain negative 1 doesn't work there. So you need something different. So I already called 1. You can't recall it. It's my solution to the problem, you know. And then negative 1 times negative 1 times negative 1 times negative 1 times negative 1. These give you a 1. This gives you a 1, and this at the very end is negative 1. This 2 gives you a 1, which means you end up with 1 times negative 1, which is negative 1. And negative 1 minus negative 1 is negative 2. Unless, actually, no, that could also be contested, I suppose. That's the 1 plus 1 equals 2 in the negative. So I guess we would need to check the proof before going forward with this. For any system that humans can see and handle directly without complicated technical devices, the number of n particles is too large, at least of the order of 10 to the 18th. Yeah, that sounds like a few too many, I would say. For such complete measurement to be possible, furthermore, for such large systems, even tiny measurement errors will make trajectory precision useless after a short time. In fact, atoms are quantum objects, and measurements are subject to Heisenberg-Atzeny principle, and even the small uncertainty introduced by that would make deterministic description futile. We can only hope for a trajectory that describes what we can observe. Number of observational states, or microstates, that can be distinguished by the observer is much smaller than the number of dynamical states. Two classical systems in the same dynamical state are necessarily also in the same observational state, but converse is not generally true. For you. Make it, will you go on the Bald podcast? if an opportunity were to present itself. I mean, I do kind of like the idea of going on the Bald podcast and just spending, I don't know how long these podcasts usually take, I don't really watch them, but going there and just for the entire time just complaining about the mall. Like, that would be my whole thing, just complain about the mall. Flame, hi there, yes, this is statistical thermodynamics. Yeah, well, it isn't yet, we're still in the classical mechanics, unfortunately. Classical with like a quantum twist a bit, but really small one. Atoms are quantum objects. Oh, don't say that, dog. That's gross. But yeah, if I were to, if I was invited on any controversial podcast, then unless I have something genuine to say, I feel like that's what I'll do. I'll just spend the entire time complaining about them all, and just watch as the host tries to stop me or like shift me to a different topic. No, I'm gonna keep with my malls. That'll be such a fun bit. Okay. For the moment, for stage also for time, but most for the stage, precisely because the same observation system may correspond to different dynamical states that follow different trajectories. Makes sense. Still, we can make predictions, only these predictions are necessarily statistical in nature. If we consider a large example of identical systems in the same observational state, we can even make fairly precise predictions about the outcome. Penrose gives the example of a woman at a time when ultrasound diagnosis can take pregnancy, but not the sex of the fetus. On the example, the observational state is pregnancy. The two possible dynamical states are the path to a boy or a girl. We have no idea what will happen in the individual case, but the same diagnosis is performed on 1 million women. We know about 51-50% will give birth to a boy. That's an... I feel like there has to be a better example for this. Right? Oh, Gabriel, that's impressive, but I claimed the x equals to 1 solution, so you only did 4 actually. You're welcome for my help, for my contribution. Hi, the life. What's 11? Which statistical thermodynamics was going. Well, haven't really gotten to it yet. I do believe. No, I refuse to. There has to be a better example of this, right? Dynamic also in the observational state. Okay, first of all, let me make sure that I understand this correctly before going on, because I feel like that's... that provides an observation max with description matter. I mean the state. Observational state. So observational would be position and dynamical would be velocity. To oversimplify, right? Reinforced learning. Not quite! All of them the reinforced learning, damn. Why they don't stem their eyes? Basically saying that the same way, you know, population of Terminator, about 51% of them will be boy. If you have a big improvement, more specific temperature, you know, it's simple. No, I know what it means. I do know what it means. I just don't understand. I just feel like there has to be a better analogy for it than pregnancy. I don't know why. I feel like it seems like such a specific... for a large number of things, I get it. If you have like apples with, I don't know, worms in them, you can't see worms from the outside, so if you look at a single apple, you don't know if there is a worm or there isn't a worm inside, but if you have like lots of them apple trees and you collect like 1,000,000 apples, then you know what percentage of them will have the worm simply because of statistics. I get that, right? Like on a single one, you can't really be certain, but in a large number of apples, you're still guessing, but your guess has a lot more wiggle room in terms of error. That's a much better. Why the pregnant woman? Feels like such a specific analogy. The pregnant woman principle, exactly. We can divide a stable prediction on examples of molecules. We need to consider the probabilities of the outcome of these probabilities will become exact numbers, and the limited number of n particles molecules tends to infinity. Makes sense. The theory, and we can just assume that, like, I don't know, 10 to the 16th is gonna be infinity, because that's close enough. I think they just wanted to relate the being pregnant thing to a specific term. The theory required for computers probabilities will be treated in chapter... ... I think you're missing a character there. I feel like there's a crucial character they're missing. I feel like it's supposed to be numbered. What chapter? Theory requiring computers probabilities. To be fair, we don't really care about computing. Unless the chapter is read dot, in which case egg on my face again. I'm so sorry. Current use of term ensembles lure. So the whole chapter clarifying to what types of ensembles we use in combination with why. Okay. Markovian postulate. We treat in chapter. Actually, you know what? That is true. I'm certain it will. Reserve the chapter, no question. I guess it's such a forced analogy. Hey, make it. How you doing? I'm doing fine. I'm doing fine. Okay. Markovian postulate. There are different ways of defining and interpreting probabilities. For types of harsh and mathematical derivations, the most convenient definition is the one of physical or frequentist probability. Alright. Given a relatable trial... that's the Greek. I've used this character before. I think this is the uppercase version of the one used for scattering time. I'm not food, but Pingy, if you have any random questions about this stuff, thank you so much, Flame. Bye. And bon appetit. I don't know what they say in Britain. Let's see if I was correct about the scattering time. Tau. And is this tau too? Go on, give me the character. To make it chart, t equals 0 cooking, t equals 1 cooked. Okay, you know what? I'll forgive the brain rot there because that's actually pretty funny. I didn't make it up, did I? No. No, I didn't. Did I? There's no scattering down, okay. I know, who cares? Who cares? Who cares? I'm just, who cares? Okay. Okay, this is tau, right? No, this is t. This is just a letter t. Okay, well, cool. Given the recursive trial t, of which a is one of the possible outcomes, the physical probability p of the outcome a is defined as this. Probability of this is equal to NA, and t is the number of times the outcome A is observed in the first n trials. Okay. That makes sense. So, number of times this happens divided by number of all times. So this happens 500,000 times out of 1,000,000, then we get 0.5. Which means this will be 50. But, and this tends to infinity because then it can, because if it tends to infinity, then this can be equal something like, I don't know, 1 divided by pi and still get the exact number. Makes sense. A trial, t this definition is statistically regular. The element exists in the same... So sorry. Ah! I'm dying. Keep in mind, we're still talking about pregnant women. I don't think we are at this point. Any math channels to learn math randomly? Free Blue and Brown, Free Blue and Brown, Free Blue and Brown is phenomenal. Free Blue and Brown is perfect in every way, shape or form. The series of one video failing and one blowing up is becoming a pattern. No, I can tell you why. It's because many people ask me why. It's because it's actually a pretty simple reason why only half of my videos like succeed. That's because before every upload, and this is actually a true story. Yeah, actually not many people know this. Before every upload, I flip a coin to the goddess of probability Fortuna. And right here it landed on heads, right here it landed on tails. Tails, heads, heads, tails, heads, tails. It's actually, that's why it's actually exactly 50%, you know? Lots of powerful presentations, no simulations. I don't have the software for simulations. I do have for chemical simulations. I have Avogadro. No, so what do you mean PowerPoint presentations? They're animations! And PowerPoint wouldn't take days to render. Okay. Iron coins 51 to 49. No, it's a special coin. It's actually a divine artifact. Nice tall. Long story. 50% of makers' videos die right before winning big. That's true. That's correct. Actual measurement quantity A, the division of the frequency A from the equation. Contribution arises from the experimental number of trials and not being infinite. Yes, that makes sense. That certainly makes sense. We need some criterion tells us whenever t is statistically irregular. For this, we split the trial into preparation period and evolution period. Make it with no any other great ones. Love Free Blue and Brown. Black Pen, Red Pen is another one. Oh my goodness, I forgot the name of the third one. There was like one. Okay, so here's the thing. So Free Blue and Brown is the best when it comes to explaining math in an intuitive way. The best. Black Pen, Red Pen is the best when it comes to like teaching math the academia style, you know? So telling you how to solve all the different things in proper ways. But then there's one more who's just really good at advanced math. I forgot the name. I can check. Maybe I'll remember. Although I'm responding to a comment. Black and Red Pen Math Basics if you're not up to that level yet. Or just solving 100 Laplace transforms, because why not? Hop right into the middle of the... right on the 50th Laplace transform and then just... Numberphile. Numberphile is great for curiosity. Numberphile is really fun for that curiosity in math and beautiful math in general. No, that's enough. Okay, 1 divided by 12 minus. That's the one. Mathologia! There we go. Mathologia is phenomenal for advanced mathematics. Would recommend. There is math and there is 528 other subcategories. I think it depends how you define subcategories, because on one hand, you could just say there is math. You can, if you try hard enough. It is, in my honest opinion, that you can approach from every field of math to every other field, if you really try hard enough. My favorite example of this is that you can do geometry using calculus if you want, simply because integrals are so convenient at describing surfaces. Mathologia is really great for advanced math though. The videos are a bit longer, they don't have quite as many flashy animations, they don't go quite as in depth about just solving it this way, but it is really beautiful maths. Trig and stats, you mean these two, how to apply them? Pretty hungry. Haven't eaten anything. I just woke up. Of course, haven't eaten anything. Try to inevitably ends up with the observation. The system after the preparation stage is regular. Sound revolution period. Can be different observational states at the time of the observation. Otherwise, the postulate would correspond to trivial experiment. The Macron postulate is related to the Macron chain event, such as chain icon, events, and curiousness state event. Or encounter L in the chain. Current chain events can thus be considered memoryless. Makes sense. Whatever Vsauce been doing this past years. Vsauce, I mean, isn't Vsauce doing philosophy more than... I always thought it was more philosophy. Like the Do Chairs Exist video. That's just Vsauce literally trying to figure out if chairs exist using different philosophies for half an hour, was it? And then Make It made a whole video about this, which is called Is Anything Real? But then no one's seen that video, and so... It's really funny how much overlap there is between my video that's mainly just physics and philosophy, simply because I'm trying to find what is real. Okay. There's a waiting time during which the system is under controlled conditions. The person needs to fulfill the Macaron postulate. The trial P that ends up in the observational state O of the system of the preparation state is called statistically regular. Okay. The only thing that's real is disco music. That's the sad truth. And AGR. Unless you define AGR as disco music. The isolation chamber has aged terribly. Oh, whoa, I'd never even thought about it this way, actually. Oh, yeah. Huh. I never thought about isolation chamber in this context. Oh. Make it as in real? No, no, no. I am the only real one, actually. I'm actually the only real one. Okay, the algorithm was very convenient for automatic dynamics computations. Stick analysis trajectories and kind of doing to analyze details and quantity search free energy. However, for analyzing evolution of the system, in terms of spectroscopic properties, the Newtonian description is very inconvenient, since spectroscopic measurements can provide the most stringent tests of theory, which will use the Hamiltonian formulations of mechanics in the following. The formulation is particularly convenient for molecules that also have rotational degrees of freedom. For that, we replace the velocity coordinates with momentum coordinates. Okay, makes sense. Can confirm I don't exist. Precisely. See, we have proof there. Life don't exist. Oh my goodness, that's woof. The more we can assume m identical molecules which are having degrees means that the total numbers of degrees of freedom is f is equal to fm. Such a system can be described by two f differential equations. Molecule Hamiltonian, the equation of motion m, non-tracting identical molecules with f degrees of freedom for each molecule. Read this. Couldn't have noticed there's no lowercase f in that. Dynamical variables is a vector of length f. Isn't that the two fm dynamical variables span the phase space? Ah, she whiz. Okay. That's a collection of pixels on the reality engine I2 on construct of the human mind. But still, what philosophy are you going with? If we're simulated, are we fake? Or are we real? Is a video game or a movie you're watching on your screen fake? Or is it just a real representation that's used to perceive it? Based on the electrons that are just trashing around in that old machine of yours. Huh? Spatial markers in the system reside. Terms on these problems that can be described in spatial momentum coordinates. Sometimes for all problems of time, Hamiltonian equation of motion applied. On the term space state, a state space is used for the space of microstates in problems that cannot be described by only spatial momentum coordinates. Ah, I'm so hungry. Maybe would hold my bipolar. Watch this. It's fun to watch somebody grow in something. Hold my bipolar. I haven't really heard of it. Realness is fake and fakeness is real. No, no, no. Realness is fake and make it is real. the real along the way. Are the fake friends? No. No. We might have to call this one early. Yeah. I'm hungry. Actually gonna need something. Tomorrow I'll try to do a longer live stream. Gotta log in. Gotta log off. Not gotta log in, gotta log off. I'm hungry. I really am, truly. I haven't ate anything in the past. Oh my goodness, 24 hours? 25? Well, that explains why I'm hungry. Okay. Well then. Thank you everyone so much for watching. Fuck bang. I'm not... no. If I don't make it... yeah, I'm gonna go and eat something. Thank you everyone so much for watching. And have a great day. Bye.